organometallic compound. Organometallic compound. So as you know, what is organometallic compound? The bond between directly bond between carbon and metal, that is called organometallic compound. And this RMGX, R is basically alkyl group, in which you know that this is your carbon and Mg is the magnesium and X is halogen. So this reagent is known as Grignard reagent. So first of all, I'm going to react this Grignard reagent, CH3 CH2Br. You can see this is your alkyl bromide or bromoalkane, you can say. And if you are going to react this with magnesium, then see what will happen. This magnesium is very reactive, so it will be CH3CH2 Br MgBr. It becomes CH3CH2 MgBr. It will come in between carbon and bromine. It will come in between carbon and bromine, and it will form this, which is called Grignard reagent. And it is very, very reactive, highly reactive. Even it react with the moisture. So if you have this Grignard reagent, CH3CH2 MgBr, and it will get in touch of moisture, that means H2O, you know, it has two parts, H plus and OH minus. So what will happen, you know, that this will be plus and this will be minus. So this plus will go to this and it becomes alkane or hydrocarbon, you can say. And you know, this is negative, so it will go to the positive part and it will be the byproduct MgOHBr. Is that clear, everyone? So this is the reaction of Grignard reagent, we can say. So please do write it and let me know. Can I change the slide?
Yes, sir.
Okay. So if I'm going to give you a question which is similar to this, you can see this is your bromine, or if it is going to react with magnesium, you will get A. And after hydrolysis or getting in touch with moisture, what will be the major product B? Let me know when you are done with this.
Sir, can you enable chat?
I don't know in this why this happens only in this class. Let me call them. मैम ये with so you can see what will be the product. This magnesium will come in between carbon and this. So you will be getting this MgBr. And after this, if you are going to do the hydrolysis, that means H plus and OH minus. And you know, this will be positive and this will be negative because metal is electropositive. So this positive will go to this and you will get butane along with the byproduct, that is this. Is that clear, everyone?
Yes, sir.
So this is the first reaction with matter. Now we are going for the second, which is Wood's reaction. And Wood's reaction, Wood's reaction is very easy. You are going to react this. Just wait a minute. Seth, can you try to send me the message in chat box?
Sir, there is no option like that.
There is no option. Okay. Okay. So Wood's reaction, it's very simple. If you are going to react an alkyl halide with sodium in the presence of dry ether, we take it in the presence of dry ether because sodium is very reactive. So what will happen? You will be getting R. Whatever is the number of carbon here, you will be getting twice. How is it possible? You can see. I'm going to explain this. This is very easy. If you have CH3X, or you are going to take 2 moles of this and 2 moles of this. See, I'm going to write it in a way uh, to explain. I'm going to write it like this. And I'm going to write the another mole of this Rx in reverse manner, or the mirror image of this. And then you are going to remove this NaX salt and connect this R to this R, and you will be getting this product. Are you getting my point? So whatever is the number of carbon in this Wood's reaction, you will get double in the product. So it's very simple. So if I'm going to give you this bromine in the presence of Na, and reacting with Na in the presence of dry ether, just let me know the name of the product.
So is it hexane plus NAVR and
Yeah,
NAVR?
it will be hexane. Whatever is the number of carbon, you can see 1, 2, 3. It will be double and it becomes hexane. Very good. Everyone getting it? Aksha, Alan.
Yes, sir.
Okay. Can I change the slide? Okay. Now the next reaction of metal is fatigue reaction. And fatigue reaction is very easy. You know what? As you can see, fatigue reaction is, this is for alkyl and this is for aryl. So if you are going to react a haloarine with sodium in the presence of dry ether, then you will be getting double of this. That means biphenyl you will get. Biphenyl. You will be like this. You can understand in the same way you are going to write it like this. And you are going to remove this and then add this too. And you will get your product. Let me know when you are done with this. Now there is another third reaction, Wood's fatigue reaction. Wood's fatigue reaction. You can see the Wood's reaction. The Wood's reaction for alkyl halide, fatigue reaction for aryl halide. But when you are going to talk about Wood's fatigue reaction, that means you are going to react react a haloarine with sodium and an alkyl halide in the presence of dry ether. So as you know that this X, X and Na will be eliminated, and this aryl will be arene will be directly connected with this alkyl. So this is what you will get. Is that clear? There.
Yes, sir.
Sir, let me know if you are able to see a screen, another screen. Are you able to see the screen? New screen?
Yes, sir.
Okay. You are going to do these questions. 1, 2. Any answer? Okay,
For the
any
first
answer?
one, is it A? No, B. D, sorry.
D or A or B? First of all, very good. This is your bromopentane to form pent-1-ene. First, you are going to write the structure of bromopentane, two bromopentane. So I'm gonna write like this. This is your pentane and it is two bromo. So I'm gonna write here. And it forms pent-2-ene. That means you are going to remove bromine from here and hydrogen from beta carbon. So there will be formation of this. As you can see, HBr is you are removing HBr. That's why it is dehydrohalogenation reaction. That's confirmed. And it is beta hydrogen is removing from beta position. So it is also beta elimination reaction. And follow Jetsev rule. That means Jetsev rule. You know that this is more stable because alongside this double bond, more alkyl group is there. That's why it follows that Jatsev rule. And this is not true. Dehydration, that means H2O, removal of H2O, that is not taking place. That's why the answer is D. Please do the second question. I'm switching it
Is
off.
it B, sir?
What is the answer?
B.
B. Any other answer? Like any, I want to ask any other students that have got the answer? Hiba, Hanifa, Mamuna, Alan. It's very simple. See, whenever you are going to prepare an alkane from Wood's reaction, the alkane will be double. So if you have one carbon, it becomes two. If you have two carbon, it becomes four. That means basically whenever you are going to prepare an alkane from Wood's reaction, you will get even number of carbon, even number of carbon. So you can see you cannot prepare heptane which is having seven carbon. So the answer is B. Question number 5.
Is it C?
What you just said?
C, sir.
C, are you talking about C or D?
C.
Can you call it C for cat, D for dog, B for ball,
C for cat.
C for cat? Okay, see, this is your KOH in which OH minus is the nucleophile. This is your 1 degree, so it will go for SN2. This is your, what we say, 1 degree, so it will also go for SN2. This is your also 1 degree, SN2, and this is your 3 degree, 2 degree. That way it will go for SN1. It can go for SN1. What I want to say is that if you remember, I told you in the previous class that this SN2 has inversion. All SN2 is inversion of configuration, and SN1 has a racemization. Partial racemization will take place. So only this option is correct. That means there is no option that are correct, because with 4 you can getting 3 also, and 3 is SN2 reaction. Are you getting my point? So all the options are correct basically. Only the this one is having SN1. Is that clear, sir?
Yes, sir.
No one is responding at all. Consider the reaction. How you are going to recognize when same degree of carbon is given? So since you know that both are nucleophilic substitution reaction, can anyone tell me which one is having more nucleophilicity? This C2H5OH or this C2H5O negative? Can anyone tell me which one will have more nucleophilicity? Saf,
The negative one.
the negative one. So always remember SN2 needs a strong nucleophile. That means more nucleophilicity, a strong nucleophile, and in SN1, weak nucleophile also work. Weak nucleophile. Okay. So as you can see, in the first one, neutral nucleophile is there. That means lone pair nucleophile is there. So this will be your for SN1, and you can see this is your strong nucleophile. So it will be SN2. So the answer is E. Is that clear? Steph,
Yes, sir.
are you able to send message? Can you check it?
No, sir. Sir, I will rejoin again.
No, just wait, Steph. Yeah, basically there is that is not problem from your side joining your call. There is another problem maybe. The next question I'm gonna give you is this question number 15. Then we are going to start alcohol. It's very easy, right? Which of the following is not chiral?
So answer option B.
B for ball.
Yes, sir.
B for ball. 3-bromopentane. Let me pentane. That means this is your pentane and 3-bromo. Yeah, that's good. This is same. So that's why it is not chiral. It is a chiral. Very good. So can we move to the next?
Yes, sir.
Yes, sir.
So I'm gonna start this alcohol. Let me know when you are able to see the screen. Are you able to see the screen?
Yes,
Please
sir.
do interact with me. It will be beneficial for you. This alcohol, as you know, and this is your phenol, and this is your ether. Everyone knows that. Now I'm going to ask some question. First of all, the classification is very basic. Like monohydric, dihydric, trihydric. So I'm going to ask you directly a question. Which one of the following is allylic alcohols? This is your option A. Option B, I'm going to give you is this. Option C, I'm going to give you is this. And option D is none of this. You need to tell me which one of the following is allylic alcohol.
Option C.
Very good. You know what is allylic alcohols? Allylic alcohol is the carbon should be sp3 to which OH is connected, and adjacent to this carbon is sp2 or doubly bonded, and this is your sp3. So this is your correct answer. Now I'm going to ask you another question. You need to tell me vinylic alcohols. Out of the above four, A, B, C, D, which one of the following is vinylic alcohol?
A.
A is the vinylic alcohol. Vinylic alcohol is carbon sp2 and OH. This is your vinylic alcohol. Is that clear? Steph, just do try to message me in chat box and click on screen share. Oh, wait a minute. Don't do that. Steph, are you there?
Yes, sir, I'm here.
Okay. Can you check whether you are able to send me a message or not? Anifa is co-host. Alan, everyone is co-host. Okay, that's why you told me how to share. And I was saying that. Can you send me a message?
No, sir.
Okay, no problem. So this is the basic classification. Now we are moving to the next part, which is very important, and it is basically, wait a minute. Everyone knows how to do the MOP, that means methods of preparation of alcohol. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so if I'm going to give you a question, I'll directly give you a question. So this is your alkene, and you are going to react this with water in the presence of H plus. Then let me know the name of the product.
Is it propane?
Propane. Any other answer? Alan?
Sir, propanol.
Propanol. Wrong answer.
It is propan to all.
Propane to all. See, there will be formation of two things, H plus and OH minus. Now, one of these will go to both of them will go across double bond. So what we need to know is that this follow Markovnikov. And what does Markovnikov says? Negative part will go to that carbon which is having lesser number of hydrogen, and positive to that carbon which is having greater number of hydrogen. Is that clear? Is that clear, everyone?
Yes, sir.
Yes.
So,
Now see, First of all, you need to take care in the previous class that I told you, whenever formation of carbocation takes place, that means the intermediate, if intermediate is carbocation, then if rearrangement is possible, then you are going to do the rearrangement. Like there is two possibility here. Basically, this is your this is your what? Basically, this is your alkene. What happens here? There will be formation of carbocation. Like how you can say that there is two probability of the product, either H plus and OH minus. You can see OH minus can also go here and OH minus can also go here. But this will be the major product and this will be the minor product. It's very simple. Now, if I'm going to give you a very easy question. Oh, wait a minute. Just let me know. Are you done with this? Saf,
Yes, sir.
are you done with this? See what will happen. I'm going to show you. There is two probability. The first probability is that the carbocation formation takes place here and the negative here, because it will be like this. Either it will go like this and either it will go like this. And you can see, and the carbocation formation can take place here and the negative charge is here. Are you getting my point?
Yes, sir.
Basically, this negative charge, as you know, this water has two part, H plus and OH minus. So this negative charge will be satisfied by hydrogen. So there will be no negative charge. Hydrogen will come and hydrogen H plus will be satisfied by that negative charge. Now tell me which one you will choose, the left one, black one, or the red one? Which one you will choose?
The red one.
Red one, because it is 2-degree carbocation and this is 1-degree carbocation and it is more stable. Now, since the carbocation formation took place, now you just need to think about it. If you are going to move on the right, you will be getting 1 degree, which is not stable, more stable than 2 degree. And if you are going to move to the left hand side, it will become tertiary. So there will be 1,2 hydride shift. There will be 1,2 hydride shift and it will be like this, and then OH minus will come into play and it will attach it. Okay, please do write it. Have you got it? So this rearrangement will only take place when it will go into more stable compounds. Okay. You just need to remember the reagent and what it actually do. It's very simple. You can also remember this if by uh, Marconi curve, but sometimes Marconi curve fails in this situation because the students this is more stable, so this is the major product. Is that clear? Can I change the slide? Okay. Now the next question is basically the next reaction is known as by hydroboration. By hydroboration, oxidation. And I'm going to tell you this is your anti-Marconi-Markov. Anti-Marconi-Markov. So you know that anti-Marconi-Markov negative part will go to that carbon, which will have greater number of hydrogens. So if you are going to react this alkene, you need to remember this reagent. If an alkene is going to react with BH3 or tetrahydrofuran, and in the second step, you are going to do a reaction with hydrogen peroxide in the presence of base, what will be the product? I already gave you a hint that is anti-Marconi-Markov. So basically, two parts will be eliminated from here. You can see H and OH again. H and OH. So please do apply anti-Marconi-Markov here and let me know the product. Name of the product, please.
Propanol.
Propanol. Very good. As you know that this negative part will go to that carbon and this will go to this carbon. So with the help of this hydroboration oxidation, we always get 1-degree alcohol or primary alcohol. And this we get from anti-Marconi-Markov. Is that clear?
Yes, sir.
Okay, can I change the slide?
So what is BH3 doing?
BH3 is your borane. Are you talking about this BH3?
Yes, sir.
This THF is a compound which is tetrahydrofuran. Tetrahydrofuran. Okay. Are you getting my point?
Yes, sir.
Okay. Now the next. So always remember this. This is very important. Please be focused here. If you have
Sir, you're mute.
just wait a minute. So basically, we are focusing on the preparation, methods of preparation. Always remember that if you are going to use an aldehyde, if you are going to react an aldehyde with mild oxidizing agent, like either you can use NaBH4 or a strong oxidizing agent, like sorry, not oxidizing agent, um, reducing agent it is. I'm so sorry. This all are reducing agent. These are reducing agent. So I'm gonna change this. At the place of OA, I'm gonna write SRA. That means a strong reducing agent, mild reducing agent. So what will happen? This aldehyde will be reduced. That means you are going to break one of the bond between carbon oxygen and then hydrogen add here, hydrogen add here. You will be getting RCH. HOH. That means RCH2OH. So whenever you are going to reduce an aldehyde to get alcohol, you will get only 1 degree alcohol. But if you are going to reduce a ketone with the help of this reagent NaBH4 or LiLH4, you will be getting 2 degree alcohol. You can see you will be getting 2 degree. Hydrogen will be added to this carbon and then OH will be here. And you will be adding getting 2 degree alcohol. Are you getting my point, everyone? Alan.
Yes, sir.
So always remember, if you are going to reduce aldehyde, you will get 1 degree alcohol. And if you are going to reduce ketone, you will get 2 degree alcohol. So this is how we prepare alcohol from aldehyde and ketone. Okay. Can I
Yes, sir.
change the slide? I'm just switching off. Can I change the slide?
Yes, sir.
Okay.
Yes, sir.
Just wait a minute. It hanged. Oh. Now see, we are going to reduce carboxylic acid. So always remember that if you are going to use NaBH4 on carboxylic acid, it will not work. It will not work. Or either if you are going to use NaBH4 on ester, it will not work. It will not work. We need a strong reducing agent like LiAlH4, like LiAlH4, lithium aluminum hydride, which is expensive and a strong reducing agent, LiAlH4. NaBH4, sodium boron hydride, does not work on carboxylic acid and ester. Always remember, this is very important. So if you are going to use this LiLH4, so this will be reduced directly. You can see hydrogen here, and you are going to break another bond since it is a very strong reducing agent, and you will be getting RCH2OH. And you can see if you are going to reduce a carboxylic acid with a very strong reducing agent, you are getting 1 degree alcohol. And you can see you are going to reduce here, then what you will be getting? It's very simple. You are going to see this is negative, this is positive, this is negative. Wait a minute. I'm gonna show you. So what you need to do to reduce ester, you are going to break this bond, add hydrogen here and add hydrogen here, and break one bond between carbon and oxygen, add hydrogen here, add hydrogen here. So on the left hand side, you can see RCH2OH you are getting, and on the right hand side, you can see you are getting 2 alcohol from this. But on ester and carboxylic acid, only a strong reducing agent will work, like lithium aluminum hydride. Is that clear?
Yes, sir.
Can I change the slide? If I'm gonna give you a question, very simple question. Please do the question. Any answer? You
So
can
the
say
reaction does not proceed.
this reaction will proceed. This is your reducing agent, but this will reduce only aldehydes and ketones. And if you look carefully, this is your ketone and this is your ester, which will not react because it will not reduce ester. So this will be converted into alcohol, but the rest part will be as it is. Are you getting my point?
Yes, sir.
So it's very simple. Now, if you revise this, can you recall this from Grignard? You are going to react this with Grignard reagent. So if I'm going to give you a methanol to react this with RMGX, you will be getting a product A, and then you are going to do the hydrolysis. Then you are going to get the main product B. Just name the product B. Can you do this? Yes or no?
Yes, sir.
Please do it. Will you be able to do this? Yes or no?
Yes,
This
sir.
it is a
Sir, I'm
reduction.
getting RCH2O MGX as A and
No, just let me know the B.
RCH2OH.
That means 1 degree alcohol. So how did you proceed? You know, this will move to this, so there will be negative, there will be positive. This will be negative, this will be positive. So it will attack here and this will go here. So you can see I'm gonna write CH2 together and you can see O negative will go with MgX and then R will be here. And if you are going to do the hydrolysis H plus and OH minus, you know this will have plus. So this positive will go to the negative and you will be getting RCH2OH. And the byproduct will be as it is MgOHX. So this is your 1 degree alcohol. So all I want to say, after two more reaction, if you are going to react this with CH3CHO, if you are going to react this with CH3CHO, please do this reaction as well as this reaction with ketone. and name the product directly the B. Any answers?
So for the first one, I'm getting 1 degree alcohol.
This one, HCHO. I'm talking about the methyl, ethanol.
Yes, and that one only. Ethanol.
You are getting 1 degree alcohol. No, it's wrong. See, I'm gonna explain. It's very simple. This will move to this, so there will be negative, there will be positive. You know, this will have negative and this will have positive, so it will attack you. So what you will be getting, you will be getting CH3CO negative, and with O negative, this will go Mg, and Mg will be positive, and here H. And you can see with carbon H was there, and on which CH3 will attack. After doing the hydrolysis, you know that H plus and OH minus is there, and this H plus will directly attack on O. So you will be getting 2 degree alcohol and CH3, and the rest part will be this. If you are going to do the same reaction with Grignard reagent with ketone, so what will happen? Again, the same follow. This will have negative, this will have positive, so it will attack here, and this will go here. So it will be CH3CO negative and Mg plus X. And you can see CH3 is there already, and this CH3 is attacking, so here it will be CH. Now, as you can see, there is H2O, that means H plus and OH minus. So this will be attacking here, and you will be getting CH3, COH, and then. So all I want to say is that this is your 2-degree alcohol. This is your 3-degree alcohol. When an aldehyde, I'm going to write here, aldehyde except methanol, react with Grignard, you will always get 2-degree alcohol. You will always get 2-degree alcohol. Or with methanol, if you are going to react with Grignard, you will get 1-degree alcohol. You will get 1-degree alcohol. And if you are going to react Grignard with ketone, you will get always 3-degree alcohol. Is that clear? If you are going to react aldehyde with Grignard, you will be getting 2-degree alcohol. If you are going to react methanol, aldehyde except methanol, you will get 2-degree alcohol. With the ketone, you will get 3-degree alcohol. Is that clear?
Yes, sir.
Okay. Can I change the slide? Just let me know. Can I change the slide? Now see, if we are going for chemical reaction or chemical properties, this alcohol react as both. Alcohols react as both. That means as nucleophile and electrophile. To act as an electrophile, only protonated alcohol do. Only protonated alcohols act as electrophile. First of all, you need to take care of this. This alcohol can act as nucleophile and electrophile. Generally, it acts as nucleophile, but when you are going to react an alcohol with proton, that means this, I'm talking about this, then it will be acting as electrophile. Is that clear?
Sir, can you repeat?
It's very simple. Alcohol has lone pair, as you know that. So it will donate and act as nucleophile, right? Yes or no? It's
Yes,
very
sir.
simple. Saf,
Yes, sir.
but alcohol can also act as electrophile, and only protonated alcohols. That means if you have an alcohol and if you want to act it as electrophile, then you are going to react first it with proton, that means H plus, and you know alcohol as a this, so it will be attacking here and it becomes protonated alcohol now. Now this protonated alcohol will act as electrophile. Are you getting my point?
Yes, sir.
Now, the next chemical properties that I'm going to start is very easy, that we have already studied. Acidity of alcohol. Since alcohol is an acid, so we are going to study acidity of alcohol. And as you know, when acid react with metal, what is the product? Salt plus hydrogen gas. Yes or no? So if you are going to react an acid, that means alcohol, with metal, what will happen? You will be getting a salt with hydrogen gas. you'll be getting a salt with hydrogen gas, and this has a name sodium alkoxide. Sodium alkoxide. Also remember, phenol react in the same manner. Phenol react in this way also, in same manner. Phenol is also act as acid. So you can see this is your phenol, and if you are going to react this with sodium, what will happen here? It's very simple. H will be replaced by Na, and hydrogen gas will be evolved. This has a name sodium phenoxide. Sodium phenoxide. Now, if you are going to react this phenol, if you are going to react this phenol with a base that is NaOH, you know what happens when acid and bases react, then salt plus water is formed. So this will be the salt, or this will be the Are you done with this?
Yes, sir.
Okay. Now this reaction is very important. Acidity of alcohol, since we are studying. So can anyone tell me which one is more acidic?
So A.
Which one is the most acidic?
So A.
A, because you can see the group which is attached with OH is plus I, and acidic strength is inversely proportional to plus I, and in this the lesser plus I is there. That's why A will be the most acidic. Then comes your C, because this is your 2 degree and this is your 3 degree. Okay. So I will be continuing from here in the next class, because I'm not well today. So I will take some extra class in the next class. Okay.